Have you ever come across an integration question which requires you to solve it using integration by parts multiple times, and it is very lengthy and time consuming? When solving such questions by integration by parts, if we stick to the basics, we will use the formula integral of u dv equals to uv minus the integral of v du. And if we are required to solve the second term using integration by parts again, we will have to repeat the steps over. As we know, the basic formula for integration by parts is the integral of u dv equals to uv minus the integral of v du. Whenever we are solving integration by parts, we have to identify the u and dv terms. Once we have done that, we can proceed to find the derivative of u, which gives us du, and find the integral of dv, which gives us v. As I've mentioned before, we are required to solve the second term, which is the integral of v du, using integration by parts. We are going to substitute v for dv1 and du for u1. So the derivative for u1 is du1 and the integral of dv1 is v1, and this gives us u1 v1 minus the integral of v1 du1. Now we can substitute this into our equation and write it as uv minus open parenthesis u1 v1 minus integral of v1 du1 close parenthesis, and if we open up the parenthesis, the equation becomes uv minus u1 v1 plus the integral of v1 du1. Now, let's say we are required to solve the integral of v1 du1 using integration by parts again. So now we can substitute v1 for dv2 and du1 for u2 and insert it into our table on the left. The derivative of u2 is du2 and the integral of dv2 is v2, and this gives us u2 v2 minus the integral of v2 du2. We can go ahead and write the following line: uv minus u1 v1 plus, now we can substitute the equation of the integral of v1 du1, which is the open parenthesis u2 v2 minus integral of v2 du2. So once again, if we open up the parenthesis, we can observe the signs in front of the terms. You will notice the alternating positive and negative signs. Positive uv, negative u1 v1, positive u2 v2, and if we keep solving the last term by integration by parts, we will continue to get negative u3 v3, so on and so forth. For the table on the left, we can add our alternating positive and negative signs for each row. We can also compare the table with the final equation and see that there is a product of diagonals. For the first row, it is positive u times v, which is in yellow. For the second row, it is negative u1 times v1 in red. And for the third row, it is positive u2 times v2 in blue. For the last row, it is a product of horizontals. Therefore, whenever we multiply horizontally, there will be an integral sign attached to it. And for this case, it comes with a negative sign. Now we are going to use this table and try to solve integration by part questions. For the first example, let's look at solving the indefinite integral of e to the power of 3x times x squared dx. For the first step, we have to identify u and dv. Since we know that it is easier to differentiate x squared, we will let u be x squared. Therefore, dv will be e to the power of 3x. Now we will differentiate the left side and integrate the right side. The derivative of x squared is 2x, and the derivative of 2x is 2. And finally, the derivative of 2, which is a constant, is 0. We can stop here as there is no point moving on. On the right hand side, the integral of e to the power of 3x is e to the power of 3x divided by the derivative of 3x, which is 1/3. The integral of this is multiplying the denominator by 3, which is 1/9 e to the power of 3x. And for the last row, the integral of this is 1/27 e to the power of 3x. We can now add our alternating positive and negative signs and proceed with the product of diagonals. As you can see, as our last row involves a 0, multiplying horizontally or diagonally to the integral of 1/27 e to the power of 3x will give us 0. So our final answer will be positive x squared over 3 times e to the power of 3x minus 2 over 9 x times e to the power of 3x plus 2 over 27 e to the power of 3x plus a constant. For the second example, we will take a look at solving the indefinite integral of e to the power of negative 2x times sine 3x. Just by visually inspecting these two variables, we know that the derivative or integral of either terms would be endless. Nonetheless, let's write down a few rows for the time being. For this example, I will let u be sine 3x and dv be e to the power of negative 2x. You may try it the other way as well. So the derivative of sine 3x is cosine 3x times the derivative of 3x, which is 3 cosine 3x. The derivative of this is negative 9 sine 3x, and the derivative of this is negative 27 cos 3x. On the right hand side, the integral of e to the power of negative 2x is e to the power of negative 2x divided by the derivative of negative 2x, which is negative half e to the power of negative 2x. The integral of this is positive 1 quarter e to the power of negative 2x, and the integral of this is negative 1 over 8 e to the power of negative 2x. But, like I mentioned before, this is endless and we could go on forever. So the question now is, when do we stop? The answer to this is when you see the terms in the first row repeat themselves, that is when you stop. So this happens to be in the third row. Now we can add in our alternating positive and negative signs and do the product of diagonals. And for the third row, we will do the product of horizontals, which will have the integral sign attached to the product. So now we can write out the integral of e to the power of negative 2x sine 3x dx equals to positive and negative is negative. Therefore, negative half e to the power of negative 2x sine 3x. For the second term, negative and positive is negative. Therefore, negative 3 quarter e to the power of negative 2x cos 3x. And for the last term, it is positive, negative, positive. Therefore, minus the integral of 9 over 4 e to the power of negative 2x times sine 3x dx. And for the last term, we can bring out the constant outside of the integral. Now, you can see that there are similar terms on the left and right hand side of the equations. So now we can bring this to one side of the equation and make it the subject. And finally, solving this, we get the answer integral of e to the power of negative 2x sine 3x dx equals to negative 2 over 13 e to the power of negative 2x open parenthesis sine 3x plus 3 over 2 cosine 3x close parenthesis plus a constant.